There's this very specific, almost painful kind of awkwardness that can only happen at like a tech conference.
Well, I think I know where you're going with this.
You're at the mixer, you got the lukewarm drink, and you ask someone, so what are you working on these days?
The standard opener. Safe, easy.
Usually. Until they look you dead in the eye and they say, I build autonomous agents.
Yeah, that is a showstopper. It sounds so impressive and also vaguely threatening at the same time.
Right. You just nod, you try to look impressed, but inside your head, the gears are just grinding. You're thinking, wait a minute, autonomous agent, is that a robot?
Is it a chatbot? A secret government project?
Or is it just a really fancy way of saying, I wrote a Python script that organizes my email?
And that confusion, I mean, it's completely justified. For a long, long time, that wasn't just happening at cocktail parties. It was happening at the absolute highest levels of computer science.
People were just slapping the word agent onto everything.
It was the buzzword of the decade. If you wanted funding for your project, you called your program an agent.
And that's exactly why the paper we're doing a deep dive on today is so important. It's called, Is it an agent or just a program? A taxonomy for autonomous agents.
Right. It's from the Institute for Intelligent Systems by Stan Franklin and Art Gracer.
And what I love about this paper is that it basically acts like a referee stepping into a boxing match. It just stops the fight and says, okay, everyone, we're going to define exactly what this word means, and then we're going to build a family tree for it.
It's a serious attempt to turn this, this chaotic buzzword
Into something real.
exactly into a rigorous scientific classification. And the places this definition takes us are, well, they're pretty wild.
Oh, for sure. By the time we're done with this, we're going to find out why a computer virus is technically more alive than a huge, complex payroll system.
And why a simple thermostat might be the closest thing we have to, like, a prototype for artificial life.
The thermostat argument genuinely changed how I look at the wall in my hallway. But before we get to the solution, to the big definition, let's talk about the mess. Why was this so hard? I mean, why couldn't all these smart people agree?
Because everyone was defining it backward. They were looking at whatever they were building and saying, this is an agent. So if you were an AI researcher working on, say, natural language,
Then your definition had to involve speaking.
it had to speak, yeah. And if you were in robotics, well, then your definition needed sensors and wheels and a physical body. It was that classic parable, right? The blind man and the elephant.
Everyone's describing the part they're holding and thinking it's the whole animal.
Precisely. So you had like a dozen different definitions just floating around.
So what were some of the big ones?
Well, take the standard textbook one from AM. That's artificial intelligence, a modern approach.
I mean, it's basically the Bible of AI, right?
It is. And they define an agent as anything that can be viewed as perceiving its environment through sensors and acting upon that environment through effectors.
Okay, see, to me that sounds pretty solid. Sensing and acting. Input, output. What's the problem?
It sounds solid until you really test it. If sensing just means getting a keystroke and acting just means printing a letter on the screen, then a calculator is an agent. A light switch is an agent. A Hello World program is an agent.
Ah, I see. It's way too broad. If everything's an agent, then the word means absolutely nothing. It's just a synonym for machine.
You got it. So then the pendulum swung the other way. You had researchers like Patty Mays at MIT adding huge constraints.
Okay.
She argued an agent had to exist in a complex dynamic environment. Or you had the Sodabot definition. Sodabot was this agent from the 90s, which claimed that to be an agent, a program had to engage in negotiation and dialogue.
So if my software is brilliant and autonomous, but it's, antisocial and doesn't want to haggle with me, it's not an agent.
According to that camp, nope, fails the test. Then IBM weighed in.
Of course.
They were focused on business tools, so their definition was that an agent is something that acts on behalf of a user.
Which works for like a digital assistant or a booking bot.
Yeah.
But what about a Mars rover? It's not really acting on behalf of a user in real time. It's mostly just trying not to fall off a cliff.
Exactly. So you had this complete zoo of definitions. Some needed mobility, some needed a believable personality like. Does it seem like a character?
It is chaos.
Total chaos. No consensus.
Okay, so in walk Franklin and Gracer. They look at this whole mess and say, we need a definition that captures the essence of agency, no matter if it's a robot, a virus, or a spreadsheet helper.
Right.
And I want to read their definition word for word because every single piece of it does some heavy lifting.
Let's hear it.
They say, an autonomous agent is a system situated within and a part of an environment that senses that environment and acts on it over time in pursuit of its own agenda and so as to affect what it senses in the future.
It's a dense sentence. It feels almost like legal text.
Yeah.
But if you unpack it, it separates the agents from the programs perfectly.
Okay, let's break it down. First up, situated.
This is the anchor. An agent isn't just a calculation floating in the void. It has to exist somewhere.
In a place.
Right. If it's a robot, it's in the physical world. If it's software, it's situated in an operating system or a network. It interacts with that specific world.
And that leads to sensing and acting.
Right.
But this is different from just input-output, right?
It is, yeah.
Yeah.
It's about the interaction loop. The
Yeah.
agent reads the state of its world, and its actions have to change that world. It's dynamic.
Okay, which connects to the part that I think is the biggest differentiator, the thing that really separates the tools from the agents over time.
Temporal continuity. This is so crucial. Most standard computer programs, they're transient. They start, they do a job, they stop.
Beginning, middle, end.
Exactly. An agent is continuous. It's
Yeah.
always there, always on, sensing, ready to act. It doesn't go into a coma between tasks.
And then there's the phrase that sounds a little bit sci-fi, in pursuit of its own agenda.
That one trips people up. It sounds like free will, like the software has hopes and dreams.
Yeah.
But agenda here just means drives. Even really simple drives like don't run out of battery or keep this file folder organized. It doesn't need a human to click start for every single action. It has its own internal motivation to act.
Got it. And the last piece, so as to affect what it senses in the future.
The feedback loop, that's the key. If I turn on a heater, I am doing it because I expect the room to get warmer, which I will then sense. My action is designed to change my future input.
And a standard program doesn't care about that. It just spits out an answer and quits.
Right.
Okay, so we have the checklist. Situated, sensing, acting, continuous, agenda, and future impact. So the paper uses this as a litmus test.
Yep. Agent or program, let's run the test.
Okay, first candidate up. The big corporate payroll system.
Yeah.
Sits on a mainframe. Once a month, it wakes up, reads a database, prints checks, and shuts down.
And the verdict is just a program.
But wait, why? It has a goal pay people. It acts. It prints checks.
But look at the overtime requirement. The paper explicitly says this program runs once and then effectively dies, or, it goes into a coma, until a human calls it again next month.
It has no temporal continuity.
None. It isn't living in the system. It's just visiting for a short while. And the feedback loop is totally non-existent. When it prints a check, does that change what it senses next month? Not really. It just processes the next batch of data.
It's a data processor, not an agent.
Exactly.
Okay, candidate number 2. This one's trickier. A spell checker.
Okay, but you have to be specific here. Which spell checker are we talking about?
Let's say the old school kind, the one I grew up with. I finish my document, I click the check spelling button, it runs through and it says complete.
That is just the payroll system in disguise. It's a program. Invoke, execute, terminate. It doesn't know you exist until you click that button.
But what about the modern one? The little thing that lives in my word processor. I type a word wrong and boom, red squiggly line.
Yeah.
Or it just auto-corrects it.
That is an agent.
Just because it's faster.
Not because it's faster. Because it's continuous and situated. It's constantly sensing your keystrokes. That's its environment. It acts by adding the red line. And that action changes the environment for the next split second. It's watching you.
And its agenda is maintain correct spelling.
You got it.
It's funny, the difference between a tool you use and an agent that helps you is basically whether or not it's looking over your shoulder.
That's a great way to put it. Agency implies a kind of vigilance. It's always on.
Okay, now for the example that I think is the most provocative one in the whole paper, the thermostat. A cheap plastic dial on the wall.
The humble thermostat.
Franklin and Gracer argue this is an autonomous agent.
And it fits every single one of their criteria perfectly. Is it situated? Yes. In the room? Does it sense? Yes. The temperature? Does it act? It triggers the furnace?
Does it do this over time?
Yes. It never sleeps. It is constantly monitoring.
And the agenda is to maintain the set point.
And here's the key, the part that separates it from that payroll program. Does it act to affect what it senses in the future? Absolutely. It turns on the heat specifically so that its sensor will read a higher number later. It's a closed cybernetic loop.
So if a thermostat is an agent and a human is an agent.
Then we're just talking about a difference in complexity, not a difference in kind.
Whoa.
The authors argue that humans are at the high end of the spectrum. We have millions of sensors, conflicting agendas, complex environments. The thermostat is at the absolute bottom, but we are on the same spectrum.
That is humbling. We're just fancy thermostats.
We're all just control systems trying to maintain our internal states against a chaotic environment.
There's one more theoretical test they bring up that I found really clever. They call it George's agent.
Right.
So you imagine a piece of software that has only one goal: do whatever a guy named George tells it to do. It just sits there, senses a command from George, executes it, and waits.
Okay.
The question is this autonomous? I mean, it looks like it has zero free will. It's a slave to George.
But the authors argue it is autonomous.
How? How does that work? If I'm telling it what to do, how is it autonomous?
It comes down to the source of the drive. The agent's own agenda is obedience. It's autonomously pursuing its own goal, which just happens to be satisfying George.
That feels like a philosophical loophole.
It is, but it's an important one for AI. Autonomy doesn't mean rebellious or creative. It means it's operating under its own control structure to satisfy its own design.
So it's self-governing in its execution.
Exactly. If I design a robot to pick up trash, and it picks up trash, it's autonomous, even though I told it to do that.
Okay, so we've established the definition. We know what is and isn't an agent.
Yeah.
But the agent world is still huge. You've got robots, chatbots.
And computer viruses.
Right.
So the second half of the paper is about organization.
Right.
Franklin and Gracer propose a natural kinds taxonomy. They literally borrow the system from biology.
Kingdom, phylum, class. I love this because it makes the whole digital world feel like an ecosystem. So what are the kingdoms?
They propose 3. First, biological agents. That's us, dogs, whales. We fit the definition. Second, robotic agents, situated in the physical world. And third, computational agents, things that live inside computers.
Okay, so let's zoom in on that third kingdom, the computational agents.
Yeah.
How does that split up?
They divide that phylum into software agents and artificial life agents.
What's the distinction there?
It's all about the environment.
Hmm.
Software agents live in real computational environments, operating systems, the internet. They have jobs to do for us.
And artificial life agents.
They live in simulated environments. They're experiments. You create a little digital world, drop some agents in, and see if they evolve or, eat each other.
Got it. Real world versus a digital petri dish.
Exactly. And under software agents, they list the classes. You have task-specific agents, entertainment agents, and then the controversial one.
Viruses.
Viruses.
I think most people would recoil at the idea of calling a computer virus an agent. It feels like giving it too much credit. It's just vandalism.
Yeah. It does feel weird, but look at the checklist. Is a virus situated? Yes, deeply. Does it sense vulnerabilities? Yes. Does it act to replicate? Yes. Is it continuous? It's arguably the most continuous. It's always running in the background, trying to survive.
And the agenda is terrifyingly clear. Survive and spread.
It's the mosquito of the digital kingdom. We might hate it, but you can't deny that it is an autonomous entity interacting with its environment.
And thinking of it as an agent, not just a bad file, probably changes how you have to fight it.
Absolutely. You aren't just deleting code. You are fighting a behavior. You're fighting something that adapts. You predict its moves differently.
The paper also mentions another way to classify these things besides the family tree, the properties matrix.
Right. This is more like a personality test for software. Instead of saying it's a robot, you check off features. Is it reactive? Is it mobile? Can it move from computer to computer?
Is it social, meaning it talks to us?
Or to other agents? The paper specifically lists communicative as a property. And believable, does it fit emotion? Does it have a character?
So you could have a mobile, communicative, non-believable agent.
Exactly. Which actually describes a lot of modern malware. It moves across the network, communicates with a command server, but it has zero personality.
Let's get into the mechanics of how you actually build one of these things.
Yeah.
Because the paper gives this great example of an agent named Sumpy.
Yes. Sumpy, the sensing, using, monitoring, processing agent.
Sumpy lives in a UNX file system, which sounds like a pretty lonely existence.
It's basically a digital janitor. Sumpy's job is to wander around the hard drive, find files that haven't been used in a long time, compress them, and back things up.
But Sumpy isn't just one block of code. This is where it gets really cool. Sumpy is a society.
This is the concept of a multi-agent system. Sumpy is made of smaller, simpler sub-agents, and the authors give them these delightful names.
We've got Wanderer.
Wanderer is totally brainless. Its only drive is to move from one directory to another. That's it. It just roams.
Then you have Compressor.
Compressor just sits there waiting for Wanderer to find a big file. If it sees one, it squashes it. That's its entire purpose.
And Backup is the same idea.
Same thing, just copies them. But my favorite is Sleepy.
Sleepy is the intelligence of the operation.
It is. Sleepy has sensors that detect if a human is using the computer. If the keyboard is active, Sleepy wakes up and suppresses all the other agents. It tells Wanderer and Compressor to stop.
So they don't slow down the machine for the user, so Sleepy puts Sumpy to sleep.
Essentially. But this illustrates a really profound engineering concept called subsumption architecture.
It is a mouthful.
It just means building complex intelligence by layering simple behaviors. Sumpy doesn't have a big brain that plans its day. It just has these little reflex loops, move, squash, sleep that compete. But when you run them together, it looks like intelligent behavior.
It looks like Sumpy is being considerate of the user.
Yeah.
But actually, it's just the Sleepy agent overriding the Wanderer agent.
Exactly. It's agents all the way down.
The authors compare this to Marvin Minsky's famous Society of Mind theory, right?
They do. Minsky argued the human mind is made of tiny, non-intelligent parts. He also called agents. But Franklin and Gracer make a distinction here.
What's that?
They think Minsky's agents are too simple. They might just be mechanisms because they don't really have their own agendas.
Ah, but in Sumpy, Wanderer actually satisfies the full definition of an agent.
It does. It senses, acts, and has a drive to move. So Sumpy is a true society of autonomous agents.
It just shifts the whole paradigm of how we think about coding. You aren't writing a recipe, step 1, step 2, step 3.
Yeah.
You're creating a little ecosystem of drives and letting them fight it out.
That is the essence of autonomous agent design. Define the goals, define the sensors, and let the behavior emerge.
So we've gone from agent being this meaningless marketing term to a very specific, rigorous checklist. You need environment, sensing, acting, continuity, and an agenda.
And that checklist is a tool. If you're a developer listening to this, you can look at your project and ask, am I building a tool or am I building an entity?
And if you want to build an entity, you need to cut the cord. Give it that temporal continuity and that feedback loop.
You have to let it live in the problem.
You know, there's one thought from the end of the paper that is still sticking with me. We talked about how humans are just high-end agents and thermostats are low-end.
Yes.
If that's true, if intelligence is just a matter of scaling up the complexity of these control loops, does that mean we are already surrounded by artificial life? We just don't recognize it because we're looking for eyes and a face, but it actually looks like a server farm or a smart grid.
That is the big question, isn't it? We tend to think of life as requiring biology, squishy cells and DNA. But if you take the functionalist view, that life is about process, about maintaining order against chaos through sensing and acting,
then the material doesn't matter.
It doesn't. And yes, a virus spreading through a network is, in its fundamental behavior, indistinguishable from a biological one. A global shipping network adjusting to supply and demand is a massive distributed agent.
So the ghost in the machine isn't some magical spark we have to invent. It's just the loop, the sensing and the acting over and over again.
Over time, in pursuit of an agenda.
Well, on that slightly existential note, I think we'll wrap up this deep dive. Next time you're at that cocktail party and someone mentions autonomous agents, you can look them in the eye and ask, so are we talking Sumpy or are we talking thermostats?
That'll definitely clear the room.
Thanks for listening, everyone. Keep sensing, keep acting, and we'll see you in the next deep dive.